In this lecture, we will learn some basics of SphereTrace by channel. Tracing in Unreal Engine is used to identify objects in a particular direction. We will be using line trace, sphere trace, capsule trace, and box trace in this course. Let us use the same reference cube and learn SphereTrace by channel. Adjust the height of the reference cube. In the level blueprint event graph, disconnect the L key event. We will use that to demonstrate SphereTrace by channel. Move it down. Add a SphereTrace by channel to the pressed pin. Add the cube initial location and connect it to the start pin. To the cube initial location, add a vector move forward with move value as 250. Connect this to the SphereTrace end pin. For the vector move forward, set the rotation value to the reference cube get actor rotation. Set the radius as 5. Now a sphere will be drawn from the cube initial location to the forward direction for 250 points. Remember, if the radius is left as 0, it will become a line trace. We have a separate line trace by channel, but remember this point. Draw debug type as for duration. When you select for duration, the trace will be visible for the draw time value. Set draw time to 2. Compile and save. Run the level, and when you press L, you can see a green color extended sphere is drawn. It looks like a cylinder. That is due to the extended sphere. When there is no obstacles in the path, the draw color should be red. If there is a block in between, then the color will change to green. In this case, the sphere trace starts from the cube initial location, which is actually in the center of the cube, which is inside the cube. That means the sphere trace starts from within the cube. That causes an initial overlap here. That means an obstacle in the start of the trace itself. We can validate this. In the output of the SphereTrace by channel, there is a struct called outHit of type hitResult, which has a lot of details about the hit result of the trace. Break the hit result. We will display some important values in this hit result using the print strings. Add 2 print strings. Let us use the append function to join 2 strings. Add the string initial overlap. Append it with the initial overlap from the hit result. Return value to the print string. Add one more append function. Add the string blocking hit. Append it with the blocking hit from the hit result. Return value to the print string. Run the level. You can see the blocking hit true and initial overlap also true. To avoid the initial overlap, let us move the trace start 20 points in front of the cube initial location. For this, we will add a vector move forward with move value as 20. Add the reference cube actor rotation as rotation. Destination as the trace start. Test the level. Now you can see the red color and also the blocking hit value as false. and initial overlap value as false. Let us now test the obstacle scenario. Move a block in front of the reference cube within the 250 points range. When you test the level, you can see that the sphere trace hits the block and from there green color starts. The remaining portion of the trace is within the block. Blocking hit value is true and initial overlap value is false. Now, just make the block thinner and test this again. You can see the green color very clearly after the hit location. Next, we will add a Boolean condition. Check if the blocking hit value is true using the branch node. If true, then use the impact point in the hit result, which is the location of the hit, and draw the location using draw debug. Now you can see the debug sphere at the hit location. Now change the draw debug type to for one frame. Test again. Now you can see the sphere trace drawing flashing for one frame. Sometimes this approach is useful. Thank you for watching this lecture. See you in the next one.